So Module 4 will deal with statistical reasoning in everyday life, and I'm going to give a very brief, and I mean very brief, introduction to statistical reasoning, and just talk about a few key concepts. If you want to learn more about statistics, you can go to Psych 220, Behavioral Statistics, and I teach that course. You can learn a lot more in-depth idea about what statistics are, how to compute them, and how to use computer software to generate the appropriate statistics you need. Now, statistical reasoning in everyday life is very, very important. People tend to misrepresent information using statistics, and you have to be able to tell what is an accurate use of statistics and what is kind of an embellished use of statistics. So teaching statistical reasoning at the undergraduate level is really necessary. Even reading graphs, something as basic as looking at a graph. People will distort the y-axis on graphs to make things look different than they really are, or to kind of accentuate a point. If there's a small difference, they'll alter the scale of the y-axis and make it out to be a big difference. And if you're not statistically savvy, you're going to be tricked by some of these, I guess, liberties or liberal use of statistics. The three measures of center, central tendency, more technically, are mean, median, and mode. And you probably understand this or learned this from, many years ago, probably starting in either elementary school or junior high school. And these are three measures of center. So the center of the set of all scores or the center of a distribution. The mode is not used very often. It's the most frequently occurring score in the distribution. So you just find the value that's represented more, and that's the mode. The mean is the arithmetic average of a distribution. So you add up all the scores and you divide by the number of scores. The mean can be influenced by a few atypical scores. These atypical scores are called outliers. And outliers can pull the mean in the direction of the outlier. So if you have if you have outliers that are positive, that means very high scores, it's going to pull the mean higher. It's going to make the mean higher. If you have low scores, it's going to make the mean lower. So the outliers pull the mean in the direction of where they are located. And the median is the 50th percentile. It's the middle score. So if you arrange all the scores in order, from lowest to highest or from highest to lowest, the median is the exact middle of the distribution. Half the scores are above it and half the scores are below it. Here we're looking at a skewed distribution. A skewed distribution means that there's a tail of the distribution. The distribution is lopsided. One end is stretched in one direction and the other end is fairly normal. And if you look at this distribution of income per family in thousands of dollars, you see the skew goes to the right. And the reason being is you see a lot of outliers on the right-hand side. Okay, and if you were to draw a curve on top of these data points, you would get a long tail going to the right side. And so the skew is always in the direction of the tail. It's always in the direction of where the outliers are. Here the tail's to the right because you have outliers. More specifically, the person that had $950,000, they must have a pretty good life, right? And then you have one person with $1,420,000. Those are your two outliers. Those are your very rich people that are pulling the mean of household income all the way to the right. As you can see in this graph, the mean household income is $140,000. But that's a distorted idea of what the measure of center, the central tendency, because of those big outliers, 950 and 1420. If you look at the median, which is the 50th percentile, you see the median household income down at 60,000. That's much more realistic of what median household income is. The mean is being pulled by those very rich people, those very rich outliers here. And the median is probably a better measure of center in this case. So whenever you have a skewed distribution, you'd rather use the median compared to the mean. The median would be a better measure of center. The mode is at 40,000. The mode is interesting as well. The mode is generally not used for statistical inference. And here, 40,000, even though more people scored 40,000 or had an income of 40,000 than anybody else, the median is probably the preferred measure in this situation. The mode is not used very often unless there are multiple modes or multiple peaks within the distribution. We also have measures of variation. So we just talked about central tendency being mean, median, mode, or the center of the distribution. Measures of variation come in several varieties as well. And this is the range, the standard deviation, and the variance. The range is a difference between the highest and lowest score in the distribution. So it's the top score minus the bottom score. These are all measures of spread or measures of diversity, right? The standard deviation is a computed measure of how much each score varies around the mean score. So it's basically the average distance from each score and the mean score of a distribution, of a set of scores. So when I say distribution, I mean set of scores. And the variance is just simply the square of the standard deviation. So if you take the standard deviation and you square it, you get the variance. Those are your three measures of dispersion or three measures of diversity in scores. The range is not very useful because of outliers. If you have an outlier, then the range is going to be distorted, right? It's not going to be a good indicator of the measure of spread. The standard deviation is a pretty good measure. However, if you have a small number of scores and you have outliers, then the standard deviation can get distorted as well, because one outlier will have an undue influence on the standard deviation. If you have a large number of scores, then the standard deviation will be a pretty good measure of diversity or dispersion within your distribution of scores. And I also want to introduce the normal curve, which is known as the bell curve to some people. It's more technically known as the Gaussian distribution. And it's a bell-shaped curve that describes the distribution of many types of data. So in psychology, the vast majority of constructs, of variables, will follow a normal distribution or a bell curve. For example, things like intelligence follows a bell curve. Physical measurements like height and weight follow a bell curve. There's just many, many variables that we encounter in everyday life that are following a normal distribution. Most scores fall by the mean of the normal curve. And in the normal curve, the mean, the median, and the mode are all the same. They're all right in the middle of the distribution. About 68% fall within one standard deviation plus or minus, so one standard deviation above the mean and one standard deviation below the mean in a normal curve. And then fewer and fewer fall near the extremities of the normal curve. And here's the standard normal distribution. You see the bell curve. This is intelligence score with a mean of 100 and a standard deviation of 15. 68% of all people have a intelligence score between 85 and 115. That means between one standard deviation below the mean and one standard deviation above the mean. And you can see that 95% have an intelligence score between 70 and 130. That's two standard deviations below the mean and two standard deviations above the mean. And the last one that you don't really see on this graph is 99.7%. And 99.7% of all scores fall between three standard deviations below the mean and three standard deviations above the mean. And that's the property of all normal curves. This 68, 95, 99.7 rule will hold to anything that's normally distributed. So let's talk briefly about statistical reasoning and significant differences. So representative samples are more better than biased samples, and the best way to get a representative sample is to take a random sample. And in a random sample, everybody in the population has an equal chance of being in your sample. The sample basically is a subset of the population of all the people you're interested in studying. So if you want a representative sample, the best way is to get a random sample, and that means that you pick people at random from the population. Every member of that population has an equal chance of being in your sample, and that sample then becomes a simple random sample, and that simple random sample is more representative of the population. However, in psychology, we generally don't use simple random samples because they're kind of hard to calculate. That means we have to have access to the entire population at all times. So it's hard to obtain a simple random sample. We use something called a convenience sample more, which means that we use the people that are available to us. The problem is the convenience sample may not be representative of the population that you're trying to study. Maybe you just got a bunch of oddballs that signed up for your study, or maybe they all wanted money. Maybe you got all the people that needed money more because you were paying out for your study. And so you got a convenience sample. And now if you have a convenience sample, replication, which is repeating the same study with new subjects or new participants, is even more important than it was before. So convenience sample not as good as a simple random sample, but it's much more common in psychology. And that just makes replication even more important. Now, in terms of telling, is there a difference between the treatment group and the control group? If I take you back to Module 3 in experimentation, you want to see if the difference is meaningful. And in statistics, we call this a statistically significant difference. And to get a statistically significant difference, what you want is less variable observations, which means that you want the treatment group and the control group, or the placebo group and the drug group being the treatment group, the placebo group being the control group. You want them, the people within each of those groups, to be less variable. That means more the same. Because if those people in each the treatment group and the control group are more similar to each other, then the variability within groups is similar. And then the variability between the groups, between the treatment group and the control group, will be more powerful. It'll be more reliable than if the variability within each of those groups is great. In order to reduce the variability within each group, we want more cases. That means we want more participants. And the greater number of participants that you have, the easier it is to find a truly meaningful difference, which we call statistically significant difference. And to obtain a statistically significant difference, we say that the results, or when we obtain that statistically significant difference, we say that the results are not due to chance, but they are due to the effect of the independent variable. So it's not just a lucky result that the treatment group is greater than the control group. It's actually a real effect due to the effect of the independent variable, due to the effect of the drug, if you go back to the antidepressant study. And we generally use a cutoff point of 5%. So we basically say that if there is less than a 5% chance that the difference between the control group and the treatment group is due to chance. So if there's less than a 5% chance that the difference between the control group and the treatment group is due to luck, then we have a real effect. Then we have a statistically significant effect. Statistical significance means that the difference between the groups is not due to chance variation, or what statistically is called error variance. And I don't want to go into too much depth in this topic because you're going to be getting a lot more of this in statistics, excuse me, if you take a statistics class. And I think you should all take a statistics class. I offer a statistics class. This is one of my favorite topics, if not my favorite topic there is. And I think it's really helpful to take this kind of class because you'll learn a lot more. It goes into a lot more depth on what statistical significance is. But for this very basic introductory class, this is sufficient to understand.